In clustered random sampling, when it's not possible to select a sample from the whole population, we can randomly select clusters or groups of subjects from different areas or different time periods even, rather than randomly selecting individuals. So in cluster sampling, you follow these steps. You first take the population, or your theoretical population, and create groups or clusters. So divide the theoretical population, into clusters. And you'll recognize this map as the state of New York. And right now, the state of New York is grouped by county. So my cluster, in this case, is a county in the state of New York. Then the next step is to randomly select the cluster. So that's what's being randomly selected, is the cluster. So we're going to randomly select counties to be part of our study in this case. So randomly select the county or the cluster. Individuals are not always randomly selected in this case. And the most simple way to do cluster random sampling then, next, would be to measure all the units within that cluster. So in this case, the third step would be then survey all the individuals in those counties, or select all those individuals in those counties to be a part of your study. It doesn't necessarily have to be a survey, obviously. Survey the population of people in each of those counties. So in this study, in the state of New York, if you wanted to cluster random sample people from New York, they were divided into clusters by county. Then you could randomly select a county. So in this case, 1, 2, 3, 4, 5. Let's say I've randomly selected the 5 counties that are shaded in red. 5 counties. And then I have all of those individuals from each of those 5 counties as a part of the study. That's clustered random sampling at the basic level. A mistake that can often be made in cluster random sampling is that once you group your individuals into clusters, one mistake is just to select one cluster and to randomly select individuals within those clusters, within that one cluster. But that's not how clustered random sampling works. What is at the basic level, what is randomly selected are the clusters or the groupings, not the individuals at this level. Okay, for example, in education research, I'm looking at, let's say, critical thinking skills for students. And I'm going to test students at the college with the ACT CAP test, CAP critical thinking test. So I need to administer this test to students. And one way to get to those students is through a course or in a classroom setting. So I'm using clustered random sampling in order to get to those students in their classrooms. I want students to take the test, but I'm going to randomly select the courses where I know they teach critical thinking. So the cluster is the course. I randomly select the course. Then I go in and administer the test to all the students that are taking that course. So that's another example of a basic level clustered random sampling. Okay, in systematic random sampling, which is the fourth type of random sampling, the way this works is after you line up all the cases. So again, you have the population, or at least you have an accessible population. You know who they are. You order them in a list from 1 to however many are in your accessible population. What's randomly selected is a starting point. Then you select every certain case after that random start. So in that case, or that nth case, that number depends on how many people you want in your sample. So in this example of systematic, we start with an accessible population of 100. This is our population, our accessible population of 100. So let's say that represents a series of students that attended orientation. 100 people attended orientation. That's our accessible population. And we want to administer a survey to a sample of them for the effectiveness of that orientation session. And let's say we just want to talk to 20 of them, for example. So the sampling interval is our population size, which is that large N, that's the notation for population size, divided by our sample size that we want, which is notated by that small n, and 100 divided by 20 is 5. So our sample interval is going to be 5. You can draw your starting point out of a hat, but it has to be somewhere between the number of 1 to 5, our sample interval. So from 1 to the sample interval, choose a number at random to start with, and then take every 5th person after that for the sample. So this is random, this is arbitrary. Any number between 1 and 5, random start on 4, and you can see this random start on 4, and then every 5th person is chosen for the sample. This is called systematic random sample with a random start. And if I select all these blue people, I will end up with a sample of 20 people that took orientation, and I'm going to go and talk to them about the effectiveness of the orientation session. So that's the fourth step, or the fourth random sampling technique we're going to talk about. Finally, you can have a sampling method that is multi-stage. A multi-stage random sampling technique is essentially any combination of the other 4 methods. So typically you will see multi-stage, especially when cluster sampling is used. So you can, let's say, cluster on, let's say I want to understand the behavior of graduating seniors in the college's service area. Graduating high school seniors in the college's service area, because I want to survey them about their potential plans for post-secondary education. And I want a random sample. I don't want to necessarily randomly pick from all of the high schools in our 5-6 county service area. That would be about 30 some high schools. So let's say I cluster by high school. So now I have 30 clusters. Cluster by high school. 30 high schools. I can randomly select 5 of those high schools. So I'm randomly selecting 5 high schools. And I know I'm only looking at graduating seniors, so I can go into those 5 high schools and then randomly select, let's say those graduating seniors, let's say there's 100 or so per high school. I'm just trying to make this easy with these round numbers. So I have 100 seniors in each of the 5 high schools. So I have a potential then of 500 people. I can randomly select from those 100 seniors in each high school. Again, random selection from each of those 100 seniors in each of the 5 high schools to come up with a sample. Let's say I'll take about 50 or 60. I'll take 60 seniors from each high school that I've randomly selected from, let's say they have 200. I'll make it better. 200 seniors in each of the 5 high schools. I've randomly selected 60 seniors from each class of 200 so that I finally have a final sample of 300 seniors. This is actually wrong now. We actually have 1,000 possible. Okay. Okay. So this is multi-stage because not only did I first cluster by high school and randomly select 5 high schools for a potential of 1,000 graduating seniors, but then I randomly selected individuals within those high schools. So this is actually now simple random, or basic random. My printing is not working very well here. So I had 2 types. I had the cluster, and then I had simple random. That would be considered multi-stage. So multi-stage is any combination of those other 4 methods. This ends this part of the module's presentation. Please move on to review the next part